In this problem here, 26, we want to find the area bounded by this curve. It's a quadratic, right? It opens up. The lines x equals 0, which is the y-axis, and x equals 4. And we are told that the region lies completely above the x-axis. So we can get the area here. We can get the area by integrating from 0 to 4 of this function. 6x squared minus 3x plus 2 with respect to x. So this will give us 6x cubed over 3 minus 3x squared over 2 plus 2x from 0 to 4. Put in that upper limit, we'll get, now the 3 will go into 6 twice. So I'm going to get 2 times 4 cubed minus 3 times 4 squared over 2 plus 2 times 4. And when you put in that lower limit, 0, since all the terms have a 0 in them, that's just a 0. All right, so what are we going to get? We're going to get 4 cubed is 64 times 2 is 128 minus, now 4 squared is 16. 16 divided by 2 is 8, and times 3 is 24, and then plus 8. And I computed that to be 112. So there's 112 square units bounded by that curve and those lines and the x-axis. Let's find the area of the region bounded by this curve. Now, this is a simple one. You know, if we wanted to draw that, we know what that curve looks like. It looks like this. And we're going to go between 0 and 1. So we're finding the area of that region right there. And we know what to do here. We're just going to evaluate the integral from 0 to 1 of e to the x dx, which gives us e to the x from 0 to 1. Put in the 1, we'll get e to the 1 minus, put in the lower limit, 0. So e to the 1 is e minus e to the 0 is a 1, so that many square units.